Hello guys, this is Nathaniel from Multi-Objective Optimization. Today the topic that I'm gonna discuss is choice function based hyperheuristic. So I'm going to explain how we can use a choice function in a hyperheuristic algorithm, how we can calculate the value of choice function, and how to use a ranking system uh, through a choice function. So first I'm gonna review a popularly used choice function in hyperheuristic algorithm. The choice function has been applied in this journal article titled "A Multi-Objective Hyperheuristic Based on Choice Function." The authors are Mashael Mashi, Ender Oskan, and Graham Kendall. It has been published in Elsevier. So the objective function that the authors are using is can be seen in equation 2. CFH is used to denote an overall score of each heuristic. So in this particular paper, three heuristics are used and they are denoted by H1, H2 and H3. So for each of the heuristic, an overall score is calculated and it is denoted by CFH. So if we see the choice function used in this paper, we can see that it has two components, function 1h and function 2h. So function 1h is a component where a ranking scheme is incorporated, which evaluates the performance of each of the lower level heuristics or meta heuristics used in an hyper heuristic algorithm. And function 2h is the number of CPU seconds elapsed since the heuristic was last called. So, to answer the first question, how we can use a choice function in a hyper heuristic algorithm, for after each iteration, we can calculate the overall score of each of the heuristic, and then uh, the low level heuristic with the highest value of choice function is the heuristic that is applied in the next iteration. So this is how we can use a choice function to select the most appropriate low level heuristic or meta heuristic that can be applied in the next iteration. So we can use the choice function as a selection method. Now to answer the second question, how to calculate the value of this choice function, of this particular choice function, we'll first I will try to explain how we can calculate the value of function 1h. In order to calculate the value of function 1h, we need to understand four performance metrics that has been incorporated in this function. So here we can see that four performance metrics titled algorithm effort AE, ratio of non-dominated individuals RNI, size of space covered or so-called S-metric hypervolume SSC, and uniform distribution of a non-dominated population UD. These four performance metrics are used to rank the lower level heuristics in this particular paper. So how we can calculate the and rank the heuristics, we'll see the calculation and I will explain in depth. Again, in this slide, we can see that uh, this particular paper is proposing a two-stage ranking scheme to be incorporated in function 1. So it is a two-stage ranking scheme, as we will see. So here we can see the two-stage ranking system or scheme. In the first ranking stage, we can see the three hyper lower level heuristics. Their performance against the four performance metrics can be seen in this matrix. So in other words, these are the performance values of each of the heuristic against each of the shown performance metrics. So we can see that there is an arrow beside each of the performance metrics. So the upward arrow beside UD, it means that the highest value among these three heuristics will be ranked as the best heuristic. So among these three heuristic, the value of 4.9 is the highest. So H1 will be ranked the best heuristic, as we can see. And similarly, the other rankings will be uh, established uh, using the same methodology. So after using that ranking system, we'll have these metrics. Okay, so moving on to the second ranking stage, we'll then count how many times each of the lower level heuristics was ranked as the best heuristic. So for example, for H1, it has been found to be the best low level heuristic two times. So H1, the value beside H1 will be 2. Similarly, the number of times H2 has been ranked as the best lower level heuristic is 3. 3 times it has been ranked as the best heuristic. So the value will be 3, and H3 been has not been ranked as the best heuristic uh, in any of the times. So the value will be 0. Okay, so moving on to the next matrix. Here we can see in the last matrix, H2 was ranked the most time as the best heuristic. So H2 will be ranked as the best heuristic according to this matrix. And similarly, the other ranking will be established. So up to here, it's very clear. The next, the challenging part is to find the function value of f1. So how we can calculate the value of f1? The authors have used an equation in this paper, that is equation 3. So here n is the total number of heuristics used in a problem. So in this particular paper, there are three lower level heuristics that have been used. So the value of n will be 3 for this particular paper. So 3 plus 1 equals to 4. 2 into 4 equals to 8. So the equation 3 becomes 8 minus addition of frequency rank and RNI rank of that particular heuristic. So again, the equation 3 becomes, for this particular paper, 8 minus frequency rank of addition of frequency rank and RNI rank of a particular heuristic. So I will give an example here. For heuristic H1, we have frequency rank 2 and RNI rank 1. So if we add these two digits, 2 plus 1 equals to 3. Now we have, according to equation 3, we have to deduct this value from 8. So if we deduct 3 from 8, we get 5. Again, for hyperheuristic 2, frequency rank is 1 and RNA rank is 1. So 1 plus 1 equals to 2. If we deduct the value 2 from 8, we get 6. So the value is 6. Thus, the f1 value of f1 is calculated for the choice function. So here we can get the value of function 1h. Now function 2h is the number of CPU seconds elapsed since the heuristic was last called. So to understand the function of 2h, I will give an example. Here we can see 5 iterations. So in the first iteration, a heuristic 1 was found to be the best, the most desirable heuristic, and so h1 was used. And then in the second, third and fourth iterations, H2 was found to be most desirable, and so in the second, third, and fourth iteration, H2 was used. And so we can see that the elapsed time of between, or to say in other way, the time that has elapsed after using H1 or after the first iteration has been a long time, as in the second, third, and fourth iteration H2 has been used. So this function f2h considers this elapsed time, and if the elapsed time is long, the function tries to bring the iteration unused heuristic in the next iteration, and thus it considers and it uses diverse heuristics in each of the iteration. And this is how we can calculate the value of a choice function. We can use a choice function for selecting a lower level heuristic in each of the iteration of a hyper heuristic algorithm. And a choice function is a very good tool to use as a selection tool, uh, because it balances uh, between intensification and diversification. So it has a component function of 1h, and it is used for intensification, and it has another component function 2h, which has been described earlier. It is used for diversification. So it has both intensification component and diversification component, and it balances these two. So it is a very good choice function to be used. And we can see that there is an large positive value denoted by alpha. It is used to strike a balance between function 1h and function 2h. So guys, this is the choice function that you can use in a hyperheuristic algorithm. See you in the next video.